We're unpacking what I can only describe as a literal technological earthquake. We're talking about a shift that completely changed how we think about the computers we use every single day. We're digging into Apple's secret chip war, their massive pivot to ARM-based silicon, and the seriously heated community debate around the whole thing. Whether you're a hardcore power user or, just someone who actually wants their laptop battery to survive a cross-country flight, this architectural clash absolutely impacts you. I want to throw you right into the reality of what the late 2010s felt like for power users. Listen to this quote from a community member named Gen X Made. They said, "The last Intel Mac I owned was the 15-inch MacBook Pro with an i9 processor. Uncomfortably hot on the bottom, fans running like jet engines all of the time. And you know what? They literally were not alone. These laptops were basically incredibly expensive space heaters. Tons of users were echoing massive regrets about buying those 2019 i9s. That was the painful, loud, and hot baseline we were dealing with." But then, boom, the script just flipped overnight. Users went from complaining about jet engines to suddenly declaring things like, x86 is dead, and the M1 was a game changer. Moving to the M1 chip was described by tons of people as being just as exciting as the massive leap to Windows 95. I mean, we went from burning our laps to total silence. The stakes for this clash couldn't be higher, and honestly, it completely blindsided the industry standard. Okay, so here's how we're going to unpack all of this. First, we'll look at the Intel overheating problem. Number 2, Apple's long-term ARM bet. 3, the M1 performance revolution. 4, Windows and the x86 defense. 5, the true cost of vertical integration. And finally, the future of silicon. Section 1, the Intel overheating problem, the breaking point of the i9 era. To understand the cure, we really have to understand the disease. Tech enthusiasts correctly pointed out that the industry had slammed face first into a thermal wall. You see, the traditional CISC architecture, which is what the whole x86 ecosystem relies on, had just become way too power hungry. To squeeze out more raw speed, those chips demanded massive cooling and massive power draw. That is exactly why you were stuck with a laptop sounding like a commercial airliner taking off just to get through everyday professional tasks. It just wasn't sustainable for portable machines anymore. And the community debate perfectly captures the core shift in how we actually measure computing performance today. It's all about the old paradigm versus the new one. In the old days, success meant maximizing absolute raw processing speed. And who cares about the heat generated or the power drained, right? But then, the community woke up to a new paradigm, maximizing performance per watt. It became entirely about getting the highest amount of work done per single unit of energy. Efficiency essentially became the brand new speed. Section 2, Apple's long-term ARM bat, a decades-in-the-making revolution. Now, while the M1 felt like a total sudden shock to the system for consumers, it was actually a highly calculated, incredibly long-term maneuver by Apple. Just think about the timeline here. Way back in 1985, Acorn creates the highly efficient ARM architecture. Then in 1990, which is nearly 35 years ago now, Apple actually co-founded the ARM joint venture. Fast forward to 2013, Apple drops the A7 mobile chip for the iPhone, and they specifically called it desktop class. And then finally, in 2020, the whole master plan plays out and the M1 arrives. As one really sharp user, Mel Gross, pointed out, we knew where Apple was going back when they introduced the A7. Phil Schiller described it as a desktop class chip. We knew it was only time. The writing was entirely on the wall for Intel. Apple literally just spent years and years scaling their mobile silicon up and up until they were finally ready to strike right at the heart of the desktop market. Section 3, the M1 performance revolution, changing the game. When the M series finally dropped, it sent an absolute shockwave through the everyday computing market. Suddenly, users were seeing unprecedented performance per watt. You had video editors totally blown away because they were doing real-time 4K rendering on laptops that were dead silent. The fans almost never kicked on. You add in drastically extended battery life, and these integrated neural engines packed right onto the chip specifically for AI tasks. This wasn't just some small incremental upgrade. It fundamentally changed what we expect our machines to be able to do. Section 4, Windows and the x86 defense. The Empire strikes back. Now let's be completely fair and impartial here. The x86 architecture is far, far from dead. The crucial thing to understand is the structural difference between these two ecosystems. Apple is basically playing with a vertical integration cheat code. They have one chip, one lockdown operating system, and one hardware stack to optimize. They control the entire widget from top to bottom. But Windows and x86, that is a massive one-size-fits-all operation. It has to support thousands of different hardware vendors, incredibly complex driver support, and decades, literally decades of legacy software. The community debate brought up a really heavy reality check for the whole ARM revolution. One user perfectly summarized it, saying, "Far too much software out there on x86 code. Legacy and backwards compatibility is Windows' strength and biggest weakness. Corporate environments, heavy-duty PC gaming, massive enterprise software ecosystems, they all rely super heavily on x86. You can't just flip a switch and move all of that to ARM. When people try running Windows on ARM right now, they constantly hit frustrating roadblocks like missing printer drivers or security software that just straight up won't run." Section 5. The cost of vertical integration, the trade-offs of Apple Silicon. Because remember that Apple cheat code we talked about? Yeah, it comes with a pretty steep price tag when it comes to consumer freedom. With Apple Silicon, you are looking at a complete loss of expansion capabilities. You literally cannot upgrade it later. The SSDs and the RAM are permanently soldered straight to the motherboard. So whatever configuration you buy on day one, well, that's exactly what you're stuck with for the entire life of the machine. On top of that, there are hard limits on massive unified memory tasks. And of course, a huge deal breaker for a lot of people, the inability to natively play heavy-duty x86 PC games. Let me share this fantastic real-world anecdote from a user named Neon Fluxved because it perfectly grounds these limitations. They said, "I tried to unzip a file which accidentally had a huge file, like 70 gigabytes, and the Mac Mini M1 crashed. My Lenovo ThinkPad P50 with 32 gigabytes of RAM opened it easily." This right here is exactly where the rigid constraints of a 16 gigabyte unified memory ARM system hit a brick wall. And it's exactly where a highly expandable x86 workstation still absolutely dominates with raw power. Section 6. The future of silicon beyond Apple and Intel. So, if we zoom out and look at the broader horizon, the tech community is already looking way past this current ARM versus x86 war. Enter the wild card, RISC-V. RISC-V is a free, open instruction set architecture. It's incredibly efficient, and the best part? It allows absolutely any company to build license-free chips. Now, community members wisely note that right now it's still pretty narrow and specialized. It needs more instructions to become a true general-purpose core. But because it's completely open source, tons of users firmly believe it is going to eventually mature and disrupt both ARM and x86. And it doesn't stop there. What else is brewing for the next phase of the hardware wars? Well, beyond RISC-V, people are watching 3D chip stacking really closely to maximize computing density. There's a ton of chatter about photonic chips, which actually use light instead of electricity to move data at insane speeds. And naturally, we have the looming shadow of quantum computing for massive, power-hungry server arrays. It is just an unbelievable time to be watching technology evolve. I mean, we've gone from jet engine cooling fans to silent, ridiculously powerful chips in just a few short years, all because of this architectural shift. So I want to leave you with this final thought. With ARM clearly winning the efficiency game right now, and the open source RISC-V coming up incredibly fast in the rearview mirror, what on earth is going to replace them both? Thanks for exploring this with me today. Keep learning, keep questioning, and I'll catch you on the next Explainer.
If you enjoy this video, please like, share, subscribe, and hit the bell to the later update from my channel. Thank you for watching till the end, and see you in the next video.